Hey guys, it's Perfect VMJ and welcome back to another video. I haven't uploaded in a little while, so I thought I'd update you guys on the Redstone computer and do a little fun project. So here's the current progress of it, and here's the actual computer. I took a break for a little while. I'm still not really working that much on it, but I'm gonna get back to into it soon. Today I thought I would just make a quick video making logic gates. If you don't know what a logic gate is, basically they're the most commonly used thing in, well, computing and other electronics. Say, for instance, an OR gate. An OR gate is, well, I'd like to say it's the simplest gate. So imagine I have this. I have two inputs. Just call these levers our inputs, and one output. If this is on, that's on. If this is on, it's on. If both of them are on, it's also on. That's pretty simple. So that's already one gate. So it's pretty much exactly what it sounds like. So let's get on to the next gate, the AND gate. Just saying, there are gates like this that have been built before. I haven't searched anything up for how to build these. Some of them I already know how to do, some of them I'm going to be figuring out during this video. So here the AND gate. It's actually pretty commonly used. You could just do this, a redstone torch, like that. And then, well, you can use the same color block, that doesn't really matter. Like that, there we go. So now only if, so that if one's on, it's still off, the other one's on, it's still off, but if they're both on, then it turns on. It's pretty simple. If you want to make a NAND gate, well, it's actually pretty easy, as NAND, or the N in front of it, means not. So there we go. If one of them on, it shouldn't do that, right? You want it to only be if both of them are on, then do this. Well, we're not going to do that quite yet. We're going to start by the NOR gate, as it's a little bit easier, at least I find it is. So we have the two inputs. We have this, or this, and then the output over here, right? Yeah. So currently, nothing's being fired into it. So there. So if this is on, that doesn't work. If this is on, that doesn't work. It's basically an inverted NOR gate. OR gate, sorry. In fact, you can make it a lot easier than this whole thing. It can actually be the same thing as the previous OR gate. I don't need these repeaters, I'm just signifying that that's where the input is, since it's just a very short circuit. There you go, and that's your output. Instead of having, in fact, you can have an inverted one. So here's your signal if one of them's on or off. It's really easy. So we'll go with that AND gate then. So as you probably noticed, whenever you're building N version of a gate, you can actually just start with the normal gate. So we'll make that AND gate. Oops. Get that ready. There we are. I'm not going to bother the repeaters this time, that's fine. So there we go, there's the AND gate. It has to be both of them on for that to be off. Oops. Okay, we'll use this over here just to make it a little easier. Okay, so we want it so only if both of them are on, we want it to output. See, I mean, that works, but when you turn one off, it's still on. A NAND gate should only be when both of them are off. I'm sorry, when both of them are off like this, then it should be active. Right now, only one of them has to be off. So that's here we have the inverted. So this circuit's probably going to be a little more difficult. Let's see. We're probably going to need a little more of a platform. Either you can block off the signal, or what you can do is have something that basically requires to be on. So like this. So this is our output. And this is always on. There we go. There's input 1, input 2. So if both are on, that means the signal passes through, right? And if both are off, but we want the opposite, so we can actually just move the pistons one block closer. Whoops. One block closer. That way, if both of them are off, then signal passes through. But if one of them is on, signal doesn't pass through. If both of them are on, signal doesn't pass through. There's probably also a better way of doing this, but this is just the method that I'm using. It works for now. Okay, next is the last gate that I'm going to be doing today. It's called the XOR Gate. And it's a lot more difficult, I guess, than an OR gate. While an OR gate, as you can see here, doesn't care if one of them's on or both of them's on, it'll still pass the signal through, which is why I find it's the simplest gate. We're going to do the very similar, except when one's on, and if the other one turns on, this will turn off. You only want one of them to be on. And this is a very common circuit in ALUs, which I have a bunch of different revisions of them over here. So let's get on the XOR gate. By the way, these are ALUs, not the XOR gates. So I'm going to make the XOR gate big. I'm not going to bother compacting it. So we're going to have the two inputs again, but I'm separating them for a reason. Because what we're going to do is we're going to have, I should probably actually have them over by 2 for what I'm going to do. So you have the signal passing through here. You're going to want to remember that. So I'm going to move this actually to the outside. Outside and up one. So what I'm going to have is red and green. So green is going to be the signal just being passed on through here in this case. So here's the signal. And then the red is going to be cutting off the other signal. So say this is on. We're going to want to pass this up, over. So if it's on, it'll shut it off. Right now the signal is on, so we're going to do... actually, no, that was fine. I didn't need to change anything for that one. That was already good. So bring the signal over here, and boom, see this one's on, so signal does not pass through. And then just do that. This works. It's just gonna, there we go. So that doesn't work, but right now this one still does work, which we don't want. So what we're gonna do is actually, instead of having that go through there, we'll pass this signal here. We can still use a redstone here, and we can put a piston here, a block here. Boom. There's your XOR gate. If one of them is on, turn this off, or this one's on, it'll turn on. But if both of them are on, it's inactive. That's it. That's your XOR gate. It's pretty simple. You can probably compact this a lot more, but this is just what I settled it for now, since I was doing that live in the episode. So yeah, that's it for now. Thank you guys for watching. If you want more updates on this computer, I can do that. Yeah. Thank you for watching. Bye.